Okay, right. You are welcome back to Integrated Systems Mathematics. Today I hope to continue my practical session. To right. I have picked some data values which is following an exponential distribution. Let me show you how that can be interpreted. Let me call it x row. Likewise, type C, I have kept all of them into my clipboard first of all. This is very primitive orientation, that's why we can do likewise. Otherwise, we need to use an Excel sheet or CSV file. Once we go furthermore, I hope to teach you everything. Right. If we need to interpret the box plot to histogram, first of all, let me show you what about box plot. Box plot. It comes. This is my dataset X. You can run it. This is your box plot. You can see now there are 3 outliers, but here I don't hope to make the outlier treatment here. Once we go furthermore, I'll show you how they can be done. We have so many methods to do that, right? Okay. And histogram, right? And our dataset is X inside of parentheses. You can, right. That's why the continuity was broken here between 100 and 150. There was no, if we have applied an outlier treatment, we should be able to make it a continuous, very smooth one, right? Even we can manage all of these bins with, but at this moment I'm not going to show you. Just I need to show you, I need to give you an idea about this distribution. This is a highly positive skewed distribution, it looks like, right? Please let me check whether it is right. Okay, this is highly positive skewed distribution, and also it looks like an exponential distribution. At this type of moment, normally we use these modules. Let me show you, right? F of x, if this is the probability density function, probability density function, I will talk about them, how they can be formed using probability mass function in my theoretical part. For now, this is a probability. I'm gonna assume this as an probability density function. So you can see f of x equals to lambda times e to the power minus lambda x, which is where x and lambda, both of them are larger than 0, right? Lambda is related to the rate of this in area, but here it's not necessary to talk, because that should be discussed with theoretical part, right? Somehow you can see that's fair enough to what is the median here. Even if you need to find out mean value, just is a central tendency measurement of this distribution. You can see that here, and also median, right? That is pretty much easy to do, right? Simply you can find out everything without any calculation, because you're gonna use R programming here, right? So now you can see that's pretty much close to 23. I didn't show you one more thing. With calculation, even we can find out this lambda, right? So let me show you how we can do it. You know the integral of this probability density function here. I'll talk about that in my theoretical part. Don't be panicked. Let me pick a color. Right. If probability of this random variable is larger than equals or larger than 24. Yeah, right. So sorry, the median was 23, right? So once it was 23, so we can say, yeah, what about that? The probability can be rewritten in terms of integral of this continuous, sorry, probability density function lambda times e to the power minus yeah. Let me do it likewise. I'm not familiar with this interface, that's why, right? Somehow simply we can say yeah. Not on this one, but also yeah, okay. I'm really sorry about that. It's better to write it lambda times e to the power minus lambda x dx. So what about the range we need to consider with respect to x? So from 0 to 23. Yeah, there is something wrong with this case. They should be treated which is equal or less than, right? Because we are gonna do it from 0 to 23. It's better right now. My approximation maybe is we can say approximately this is going to be equal to 0.5 because I have picked here the median, that's why. So using this I'm pretty sure that you may be able to find out lambda, and you can run up this probability density function for others also. This is an approximation, not the exact value. Even we should be able to do these outlier treatments, then only we can make it and make it a stable data set, right? Okay, so hope you could get the idea what we are going to do. And here this is just a simple module or a module what I have presented to you today, right? I hope you guys may join with our theoretical part also, otherwise you're not able to understand what does it mean by probability density function, because I have discussed up to probability mass function, right? Okay, thank you. I'm Sapumal Sena Sankasaka.